Okay, today we're going to look at sine, cosine, and tangent. And we're going to be just sort of reviewing angles a little bit, see what you've seen before. So with angles, we can define an angle as a rotation of two rays. So this here is a ray is a line which starts at a point and continues in one direction. This is what we call a ray. So we have a ray here, goes out in that direction. We have another ray here in this direction. This gives us an angle which is defined here. This we call the initial position, and this we call terminal ray. So we rotate from the initial position round in a anti-clockwise direction and place the terminal ray somewhere, and then we define an angle of a given size. Often talks about standard position, so you could define an angle which isn't standard position. This same angle here could be about something like that. It's no longer in standard position. We have to sort of bring this one down till it lies on the x-axis, the positive x-axis, and then it's considered to be in standard position. As you know, this is the unit circle. So we take a circle of 1 unit length and we can create the unit circle. This means that the radius here is going to be 1. And this has some special properties. So what we end up now is, in order to find this sort of a length here, we have a right angle triangle here. That's a right angle. And this side here is the opposite. So the length of the opposite is always going to, the sine of this angle is going to be the opposite over the hypotenuse. So y over 1, so it's just y. This means this is equal to sine x. Likewise, we're going to have this length here as cosine x. So the coordinates of point P become cosine x, comma sine x. This is what we call the unit circle. We use this for a lot of problem solving. Can we see the tangent in the diagram graphically? Well, you can. The tangent is y over x. Now, y is the change in y because it's changing from 0 up, and x is the change in x. So it's change in y over change in x. So another definition for the tangent is the slope of the terminal ray. So the tangent of theta is the slope of the terminal ray. Sorry, I've used a bit of x there. It should be sine theta. We've defined our angle as theta. So sine theta and so on. It's better to remove the confusion between x and the angle. So P is cosine theta, comma sine theta. Okay, this is revision from last year. You should understand and be familiar with most of this. So the radian measure, if you haven't seen it before, 1 radian measure is the angle when it's rotated, so that the terminal ray is at a point where the length of the arc here, this length here, is equal to the radius. So in this case, where we have our radius equal to 1, then the sine of the arc the length of the arc should also be 1. This defines a radian measure, which is roughly 57 degrees. All angles in math and science are measured in radians. Degrees are useful. We tend to only really use degrees for geometry, architecture, everyday life, but when it comes to math, science, engineering, the standard unit, the SI unit for angles is the radian. This makes calculus much, much easier, is the main reason. Okay, one of the things you need to be able to do is to produce the exact value table. You need to be able to produce this quickly and easily. So in order to do this, what we need to do is we need to understand how to find these angles and complete this table. I'll show you how to complete it and explain where it's coming from, and then I'll show you how to complete it quickly. So first up, we need to be able to convert these simple angles into radians. So if we take the unit circle, like this one, the most important thing to remember is this is 1, 0, and this will be 0, 1. So if you remember, in the unit circle, when we draw our terminal ray, then the coordinates here is cosine of theta, sine theta, and there's theta. So if the terminal ray stays there and it doesn't go anywhere, the opposite has no height. So the sine has no height, it's going to be 0. So this one here is going to be 0. And the cosine is to go straight to this particular point there. So it's equal to 1. We rotate it up to there, and then the sine now is 1 and the cosine is 0. How do we convert into radians? The most important thing to remember is that if we rotate round to here, we are getting 180 degrees. So that is actually pi radians. Remembering that pi radians equals 180 degrees is really, really useful. Notice that radians don't need a unit because it's an SI unit. Angles are assumed to be in radians, so it doesn't actually need a unit for you on that one. Just pause the video a second. Okay, you're gonna have to forgive me a bit now. My iPad has given way. Let's see what we can do here with my fingers. Okay, so we want to be able to complete the exact value table. As we've seen, this one is going to be 0, this one is going to be 1, this one is going to be 1, this one is going to be 0. We need to divide up these, so we've got 180. Let me see if I can draw like this. 180 is equal to pi. So this means that if 180 is equal to pi and we divide both sides by 2, we get 90 is equal to pi over 2. So this one here is pi over 2. If we take 180 and divide it 3 times, we'll get 120 and then 60. So this one is pi over 3. If we take 90 and divide it by 2, we get 45. So this one is pi over 4. If we take 60 and divide it by 2, we get 30. So this one is pi over 6. This one is also 0. Now, these bits here through the middle. You need some special triangles for that. You should have done the topic on this. This is what I explained in IM3 quite a bit. They call it special right triangles. And your special right triangle, your first one is this one. It's an equilateral triangle. All the sides are equal to 1. So the angles here are all 60. You split this triangle in half, and this angle up here is 30. So this length here is a half, and the other length given there is going to be given by Pythagoras' theorem, which is going to be 1 squared minus a half squared, square rooted. This is going to give us the square root of 1 minus a quarter, which is going to be root 3 over root 4. which will going to be root 3 over 2. So this length here is root 3 over 2. Okay, so using the special right triangle here, if we take 30 as being our angle theta, then the opposite is a half. So this one is a half. Using the special right triangle, where 30 is the defined angle, the adjacent is root 3 over 2. We'll do 45 later. So, the adjacent is the cosine, root 3 over 2. Having this one as the defined angle, it's now 60 degrees. The opposite is root 3 over 2. You saw it drawing that one in earlier. So this is root 3 over 2. The adjacent is a half. So this one is a half. We have another special right triangle, which is also this one. It's this time, this length here is 1, this length here is 1, and this angle is 45 degrees. So this one is also 45 degrees. Using Pythagoras' theorem again, we get 1 squared plus 1 squared, meaning root 2 is the length of this side here. So this time the sine of the angle is the opposite over the hypotenuse, which is 1 over root 2. So 1 over root 2 can be rationalized to be root 2 over 2. The adjacent is the same, so the cosine value is the same. To find the tangent values, we use the definition of the tangent, which is that tan x is equal to sine x divided by cosine x. So we take 0 divided by 1, and we get 0. We take 1 over root 2 divided by 3 over root 2. Well, the root 2's will cancel each other out, and we get 1 over root 3. We take the same number and divide it by itself, you'll get 1. If you take root 3 over 2 divided by a half, the 2's cancel out, and you end up with root 3 over 1, which is root 3. The last one, you take 1 divided by 0, it's undefined. So this is how we create it. Creating it more quickly, you need to basically, this is going to be 0. We start at 6, we skip 5, and we count down 4, 3, 2. For the sine, for all of the other values, you only need to memorize these 3. Get used to memorizing these 3. It's going to be just a half, root 2 over 2, root 3 over 2. In fact, there's a pattern to that. Look, root 1 over 2, root 2 over 2, root 3 over 2. In fact, 90, which is 1, that's root 4 over 2, if you really want to. And in fact, the 0 is root 0 over 2, so it's root everything over 2. So that is going to get root 1 over 2 is 1 over half, 1 over 2. This is root 2 over 2. This is root 3 over 2. Just memorize those, that's it. Then all you have to do is write it backwards. For the tangent values, you just divide the sine value by the cosine value. You get 0 divided by 1, you get 0. Now on this one, just remember to ignore those ones. So it's just 1 over root 3, 1, root 3, and then undefined. Get used to doing this quickly. Okay, stop the video at this point, work together with your partners, and have a go at the warm-up activity on radian measures you'll find on the Google Classroom. Pause the video now. Discuss your answers with your friends. Okay, welcome back. Let's have a look at a little bit more. So what we're going to do is use the unit circle a little bit to find sine, cosine, and tangent values. So in this first question, the figure shows a circle centered at the origin with angle measure of theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of point P are x, y. Cosine theta, sine theta. Don't forget that. The distance between the origin and P. Which of the following is true about the cosine of theta? Now what we want to notice here on this one is this has been enlarged. Everything has been multiplied by 3. So we've stretched it, we've dilated the unit circle. It's no longer a unit circle. So the coordinates of P are going, we have to work this one out. The coordinates of P on this one Okay, so we don't quite know where that is. Let me just read it through for a minute. Okay, so the cosine of theta is equal to the x-coordinate divided by the radius of the circle. So because the radius of the circle has been enlarged to 3, it's going to be this one, x over 3. Excuse me. Okay, for this one here, we're just going to practice using the unit circle a little bit. So here we have an enlarged unit circle with radius 5. We have your standard 3, 4, 5 triangle here drawn. We love that one. That's the best Pythagorean triplet. The figure shows a circle with radius 5 centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. What's the sine, cosine, and tangent value? So we need to reflect point 3, 4 down to P. Now if you notice that the x value is going to be the same. The x value is going to be the same. So this is the x value, this is the x value, this is the x value. All of those lines are 3. This vector here is 4. If you reflect it down in this direction, then the vector becomes minus 4. So we have point P is going to be 3, minus 4. So the sine of theta is going to be the y coordinate divided by the radius. So minus 4 over 5. The cosine of theta is going to be the x coordinate, 3, divided by the radius. The tangent is going to be the sine divided by the cosine, the denominators will cancel, and it will give you minus 4 over 3. So let's practice just reflecting points around a bit in the unit circle. This length here is x. So the x coordinate here is going to be x. This length here, or this vector now, is going in the opposite direction. So this vector here is plus x, the other vector is going to be minus x. So this one is going to be at minus x. This one is going to be at minus x. We have a vector going up in this direction, it's going to be y. So this length here, vector is y, this length here is y. We reflect that vector downwards, becomes minus y. So this is minus y. This one here is minus y. This is x, comma, y. This is why, if you notice the cosine value here is positive, the cosine, sorry, let me move on. I'm not going to type them in there. So find the sine of the angle whose terminal ray intersects the circle at point S. Point S is this one. We want the sine. The sine is the red one. So this one is going to be, the sine is equal to minus y over r. Notice that it's not defined as a unit circle, it's defined as a circle of radius r. So we have to bring the hypotenuse back in again each time. This is going to give us the sine of theta is equal to, where we were, s, so minus y over r. Find the cosine of the angle at Q. So Q is up there. So the Q is the blue one, the x value divided by the radius. So on this one we want the cosine of theta is equal to minus x over r. And our last one, find the tangent of the angle whose terminal ray is at r. So r is in the fourth quadrant down there. Can't quite see it. It's the x value divided by the y value. Sorry, it's the y value divided by the x value, the sine divided by cosine. So the tangent of theta is going to be minus y divided by minus x, which will give us y over x. They'll both become positive. Okay, bit of problem solving for us now. Our last question for today. Let theta be an angle in standard position whose terminal ray coincides. So let's do a little bit of a sketch of this one. Got a couple of lines like this one. We've got a line going off in this direction. Come on. It's in the second quadrant, so it's like this. The gradient of that is minus 3. So the slope is, so the tangent of the angle is going to be minus 3. How about for the sine value? Well, for the sine value, we're going to need to know what the y value is. Excuse me a second. Okay, so better finish this one off quickly. We need to find the length of, so we've got our right angle triangle. Let's draw a right angle triangle over here, like this. if we define this as x, then this length here is r. Up to this point, this length here is y. So those all relate used by the circle's equation, which is going to be x squared plus y squared equals r squared, will give us x squared plus negative 3x squared equals r squared. So 9x squared, that will give us a total of 10x squared plus r squared, which means that x, depending on how big the circle is going to be equal to x is going in this direction, so it has to be negative, so it's going to be minus, because we're square rooting, so you get plus minus. Sorry, I'm going too quick. Let me rearrange this one a little bit. You'll get x equals r squared over 10 all square rooted plus minus. Because it's going in the negative direction, we ignore the positive one and only take the negative one, which gives us minus r over, that's an r, looks like a square root symbol. Unfortunate in this question. R over root 10. So that's the x coordinate, the x coordinate. The y coordinate is going to be 3 times that. So I'm just going to finish the video now. That means that the sine value, the sine of theta, is equal to y over r, which will be equal to our y value. Which will be equal to minus 3 bracket minus r over root 10 all over r. We'll make some space to finish this off. So let me bring that back. View. So we have got here equals (3r over r root 10). So we have got 3 over root 10. Okay, I'm going to skip the cosine one. We're out of time there today.